Hello students, all the second year MPCS and BHCCS students, let us discuss about the spanning trees in data structures. That is in our fourth unit, we are having the spanning trees topic. Let us discuss about that spanning tree topic. So, spanning tree. What is a spanning tree? Spanning tree is a subgraph of graph of vertices and edges with no cycles. I think you all know about graphs. We have discussed about graphs in our previous topic. Graphs are nothing but a connected nodes with edges with the cycles. Graphs are nothing but a connected nodes with edges with the cycles. So we discussed about this topic graphs in our previous topics. So let us discuss about the spanning tree. So spanning tree is a subgraph of vertices edges with no cycles. Okay, so what are the rules we have to follow when we are when we are constructing a spanning tree? So spanning tree should connect all the vertices, of graph. Okay, and if graph is having n vertices, then spanning tree should have n minus 1 edges. And the third point, should not contain cycles. So spanning tree should connect all the vertices of graphs. If graph is having n vertices, then spanning tree should have n minus 1 edges, and it should not contain cycles. So let us see what I think you all know about vertices and edges. When we are discussed about graphs, I have told about what is a vertices and what are the edges. So again I will explain. Let us see. Example. Here I am drawing a graph. A, B, C, D. Here A, B, C, D are vertices. A, B, C, D are vertices. And here these all are edges. Okay, so in this graph we are having 4 vertices and 4 edges. Okay, so please verify your material. In that material I have given about the graph topic. In that material it is clearly explained about a graph and what is the vertices and what are the edges. Okay, so here this graph is called as a cyclic graph. Here this graph is called as a cyclic graph. And what is a cyclic graph? Means this is a graph with edges, vertices, cycles. Okay, this is about a graph. And let us see. Now we have discussed about graph. Now let us see how to create a spanning tree of a graph. Okay, so continuation of the previous video. Here we are creating the spanning tree graph. So rules, what are the rules we have to follow when we are creating the spanning tree? So number of vertices So follow the video. In previous video we discussed about graph. So here in this video what are the rules for creating a spanning tree? So by the help of this graph we are creating the spanning tree. So rules: number of vertices must be equal in both graph and spanning tree. Okay, and the second one, we should connect all the edges as n-1 edges. So number of vertices must be equal in both graphs and spanning trees. Number of vertices must be equal, and we should connect all the edges as n-1 edges. Okay, so let us see. Here this graph, how we are creating. This is one possible way of creating the spanning tree, and another possible way. This is another possible way, and this is another possible way. This is another one. Here 4 possible ways are created as minimum spanning tree. Okay, so note that here no cycles. See, this graph is not having any cycle. This graph is also not having any cycle. And this one, these four graphs are not having any cycle. So this is one of the rule which we are discussed in the rules. Okay, so here n minus 1 edges is one of the rule. So here in this graph there are 4 edges and 4 vertices, but where here in minimum spanning tree there are 4 vertices minus 1, that is 4 edges, sorry 3 edges, 4 minus 1, 3 edges, 1 2 3, and this is another way, and this is another way. That means these all are the 4 ways, 4 possible ways. Okay, 4 possible ways to create a minimum spanning tree. Okay, so please follow these graphs so that you may be understand very easily. So all these are cyclic graphs, nothing but spanning tree. Okay, so students, here I am giving another example. See, this is in a rectangle way. So A, B, C. This is a graph. So how we can convert into spanning tree? See, how many possible ways? A, B, C. Okay, and A, C, B, right? And A, B, C. So here 3 possible ways to create a spanning tree. Okay, so let us discuss about minimum cost of spanning tree. So how to calculate minimum cost of spanning tree? So let us take an example. So see here in this example, same above example I am taking here, A, B, C, and the weight or the cost of A to B is 5 and A to C is 2 and B to C is 3. Let us assume these values. So in what is the cost of this graph? Cost of this graph or weight of this graph or weight of this graph is 5 plus 2 plus 3, that is 10. Here the cost of the graph or weight of the graph is 10. So what are the possible ways to minimize this graph? So see here, same A, B, C. So A to B 5, A to C 2. Okay, the cost of this weight of this graph is 5 plus 2 equal to 7, right? And here another example, A, B, C, and here 5 and A to B 5, B to C 3. So 5 plus 3 equal to 8. Okay, and another way. So A, B, C. So here A to C 2 and B to C 3. So 2 plus 3 equal to 5. So the minimum way of the graph, minimum spanning tree of the all these three possible minimum spanning tree cost is this one, last one, that is 5, right? So the cost of the minimum spanning tree is 5. Okay, you have to calculate the minimum spanning tree weight or cost in this way. Okay, graph may be constructed in several possible ways which are in a non-cyclic way, that is here this is in a cyclic graph, and all these are not a cyclic graphs. That means here 1, 2, 3 vertices and 3 edges. Here the vertices must be same, but the edges must be n minus 1 edges. So here 2 edges, but all the vertices are connected with each other, and here we are calculating the minimum cost. Like this we have to calculate the minimum spanning tree cost. I think students, you all understood this topic. If you are having any doubts, means please put the message, I will answer it.